People who may be in battle, okay? Well, that is definitely the sympathetic system in charge. And therefore, they don't think about the, having to constantly eat or go to the bathroom. Because these other systems have said, the body has said, okay, you can wait. Now, that can become an issue, all right, where it becomes a situation where their body does kind of get conditioned to that effect, and they may constantly have something that goes along with that all the time, okay? So, but under conditions like, I had a professor that I worked with, and he had been in the Vietnam War. And, he would talk a little bit about it, And so, I can't remember what the topic was, but he said, well, Danette, this is what it means, where, can't really say what he said, okay? But basically, a part of your body closes. Y'all use your imagination on going to the bathroom. All right, the two parts of the body. And one that'll, okay, and then you just not going to go to bed. Then he was like, okay, we were out in battle. He said, when we were out in the field, he said, you didn't go to the bathroom. He said you would get so backed up that when you did get back to the fob, you would be constipated and you wouldn't be able to go to the bathroom, okay? And so he said, this is what's happening when that occurs. So, I was like, wow. I mean, never been there, don't know anything about it, but that just seems painful.
Well, what about, okay, so like a lot of long distance runners, when they do like marathons and stuff, they have to go to the bathroom. So what's that like?
Now, in that situation, most likely, they have been feeding their body.
Yeah, they do.
And they have been providing the fluids to the body.
Okay.
So it doesn't completely shut down, okay? They will have to go to the bathroom. But if you think about other situations, like situations that are putting you in a situation of fear, okay? Those are going to be ones where they're not getting to feed the body. They're not getting to water the body. Everything is actually pretty much restricted. So the system has to meet that demand.
In my experience, I've seen the opposite. During my first firefight, we had soldiers who wet themselves.
Now, the body's urinary tract, okay? When we learn about the anatomy of that, there's actually two muscles involved. One of them is a skeletal muscle. One of them is smooth, which means it's affected by the autonomic nervous system. In cases of something like that happening, the skeletal muscle around the urethra, okay, that one is what we learn to control when we are taught or when we are potty trained, okay? The one, that smooth muscle, you can't. It just basically says you can't hold anything else.
So one muscle just relaxes while the other one is already doing its job. So
and it just goes.
Okay.
Yeah. Mm-hmm. But then you probably notice as the fight goes on, they don't have to go.
Right.
Yeah, it gets held. Yeah. So, what we're going to find, this system, the parts of it, the components, both the central and peripheral nervous system. Because if my information goes in, I got to have a way for the effect to come out. You have a question?
I'm just going to ask a question, but you kind of fit in.
So, what we're going to see, the majority of the nuclei that are going to have an effect over this system we're going to see in the hypothalamus and brainstem regions, because this one is going to be involved with my endocrine system. My motor neurons, the ones that are going to help carry out the response, the effect, okay? They're going to be in the spinal cord, and then, ta-da, peripheral ganglia. Do you remember those? All right. Central nervous system. Okay, is everybody in agreement with me? Peripheral, anything that's exiting through the bones. And then, do you remember ganglia? Now, I'm not talking the posterior root ganglion. That is inside the bone. Peripheral ganglia, meaning outside my spinal cord. So the representation on this model right here, it's trying to show you the yellow. Yellow is always representing nerves, okay? And then it's trying to show you these little pink notches or bumps or whatever, okay? That would be the ganglia. Be sure to take a look at this when you take a break, okay?
And you said the peripheral ganglia exit through the...
Peripheral means we have now exited from the CNS. So that means whatever has come out of the bone, so out of the vertebra.
Are you talking about the chain?
The chain.
So anything
The chain ganglia. So at break time, be sure to note the yellow, because yellow is representing my nerves, okay? And then these little pinkish bumps, knots, or whatever you want to call them, okay, are going to be my ganglia. Now, we are going to use my dorsal root ganglion, okay? But I'm not referring to, you know, the actual spinal cord itself, because that's going to be my central that it has to use. I got a picture. All right, guys, hold on to that thought, because I got pictures for you, and that'll explain it for the most part. So our fibers that are going to have to deal with the information travel through my cranial nerves. Think of the vagus and the glossopharyngeal that we just mentioned for the blood pressure, and my spinal nerves, the ones that are exiting out of that vertebral column. It's similar to what we saw with that peripheral nervous system, the one that exits the spinal cord and feeds everything else, okay? It's similar to that, but the pathway now has to meet the organs of the body. So the pathways that it's going to take, we're going to have a pathway where we use part of a somatic neuron, a peripheral neuron. So therefore, the neuron from either the brainstem or the spinal cord that can reach somewhere, we're going to use a part of it. Not the whole thing, but a little bit of a portion of it. The autonomic, we're going to see that with this chain that exists, okay, we're going to have to use, once again, a part of that peripheral nerve coming out, and we're going to have to get to that chain in some way. So we're going to have the pathway use a little bit of those peripheral nerves. So if we think about what we learned with the skeletal muscles, that nerve, that spinal nerve, simply exited and met the skeletal muscle. Is that correct? Now, with my autonomic nervous system, I'm going to use a little bit of that spinal nerve. And then I got to make some other pit stops along the way to get to my target organ. The response is not going to travel from that whole spinal nerve to the muscle. It's now going to make some little pit stops and go to the organ where it's needed. But for the information to enter and exit, I need a little bit of my spinal nerve. Okay? Now, just hold on to that thought. Okay? As the information passes, we are going to say, I'm going to have a pre-synaptic neuron and a post. The ganglion that I just mentioned, that I want you to look at, running along the side of that spinal cord over there. The first thing that it's got to do, it's got to exit by way of my spinal nerve, and it's got to go to a ganglion where it synapses. So this one would be my pre-synaptic fiber. After it synapses, the fiber that extends to the organ is my post-synaptic.
Which one's the one?
The one from the ganglion to the organ. We have our ganglion now to be concerned about. There will be ganglions. Ganglia. So if we think about what we've learned to this point, everything we've done pretty much has dealt with an effect on skeletal muscles. Because skeletal muscles, okay, the effectors were relatively simple. Now, when we begin to look at our autonomic nervous pathway, okay, we're going to see that this effector is going to be different. And here's the other thing we're going to get. The response can either excite or cut off that response. It can either be excitatory or inhibitory. So, if we think about our autonomic nervous system, we got to deal with information coming from certain areas of the spinal cord. So my sympathetic division is also called my thoracolumbar division. What does that mean?
The radic and the lumbar region.
Yes. if I'm looking at my spinal cord, I have the cervical region, the thoracic region, the lumbar region, the sacral region, and my coccygeal. So thoracolumbar is telling me these two portions. So information from the sympathetic division gets passed out here, moves out. The presynaptic fibers are short, the post are long. Take a break, be back at 9:30. We'll pick up at that point.